Hi everyone, this video is on probability distributions, the start of it anyway. So a random variable is a quantity whose value depends on the outcome of a probability experiment. Random variables are represented by capital letters. Discrete random variables have a finite or a countable number of possible values. Continuous random variables can take on any value in some interval. Two important facts: that probability distributions and probabilities still have to go between 0 and 1, and the sum of all probabilities has to equal 1. So remember, this symbol here means the sum of. Sigma notation, sum of. So the sum of all the probabilities equals 1. First example, a drawer has 5 black socks and 3 red socks. 2 socks are removed without replacement. Find the probability distribution of X, the number of red socks removed. So first of all, we're going to need to draw a tree diagram. We're going to have the first sock that's removed, and that could be black or red. Then the second sock could be black, red, and then black and red. Our probabilities, there are 5 black socks and there's 8 socks in total, so we've got 5 out of 8 for the first sock and 3 out of 8 for the reds. Now if we pull out a black first time, the probability of a black on the second would be 4 out of 7, because we have 4 black socks left and 7 in total, and then there would be 3 out of 7 for the reds. Now if a red got pulled out first, then we'd have 5 out of 7 for black and 2 out of 7 for the reds. Our outcomes, this one would be black, 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 red, red, black, and red, red. And then we can work out our probabilities. This one would be 5 out of 8 times 4 out of 7, which is 20 out of 56. The next one of black, red would be 5 out of 8 times 3 out of 7, which equals 15 out of 56. Red, black, 3 out of 8 times 5 out of 7, which equals 15 out of 56. And then red, red would be 3 out of 8 times 2 out of 7, which is 6 out of 56. So that's the probabilities of all the possible options. Now, our probability distribution is the number of red socks removed. So we're going to create a table. This is what a probability distribution table looks like. Always has 2 rows. The first row is always X, and the second row is our probability. And it always uses this type of notation. So X is what outcomes we're looking for. So the number of red socks, we could have 0 pulled out, 1 pulled out, or 2 pulled out. We've got 3 options of how many red socks could be pulled out. And then we just fill in our probabilities. So the probability of 0 red socks would be black, black being pulled out, which if we look here is this one that I've just starred. So that's 20 out of 56. 2 red socks would be red, red. I'm just going to go to the last one, which would be the second one that I've starred, so that's 6 out of 56. And then 1 red stock is the 2 middle ones, and it would be those 2 added together, which is 30 out of 56. Now you can simplify these fractions if you wanted to, but your calculator might do that automatically. And if you did, it would be 5 out of 14, 15 out of 28, and 3 out of 28. And that's what probability distribution looks like. It's that table we've just drawn there. Right, example 2. The table shows a probability distribution of Y, the number of cracks observed in a 1 kilometre region of sewer pipe. And part A, we want to find the value of K. Now the main thing to remember here is that all the probabilities in this row here have to equal 1. So just like normal probabilities, all the probabilities in a probability distribution have to add up to 1. We can work this out because we know that 0.45 plus 0.3 plus 0.15 plus K has to equal 1. So we can put that in, work it out, and we'll find that K equals 0.1. Part B, find the probability that Y is less than or equal to 1. So once again, now we can just go to our table. For it to be less than or equal to 1, we need the probability that y is 0, and we need to add that to the probability that y could equal 1, because that satisfies what we've been asked to find, that y is less than or equal to 1. Put our values in, so 0.45 plus 0.3, which would be 0.75. And the last one, part C, we've got the probability that y equals 0 given, remember that straight line is given, y is less than or equal to 1. To work this out, remember it's a probability that y equals 0 and the probability that y is less than or equal to 1 is what we want, all divided by the probability that y is less than or equal to 1. Now, probability that y equals 0 and y is less than or equal to 1 is just a probability of y is 0, because y is already less than or equal to 1. It can't not be. So it's just going to be the probability of y equals 0, which is 0.45, all over the probability that y is less than or equal to 1. We found that in part B, which is 0.75. Put that in your calculator and you'll get 0.6. And that's basically probability distributions, and quite often you get asked these types of questions like this example here with them.